so we're going to continue our work with the law of sines. When are the 3 times we can use the law of sines? Angle, side, angle. There is one. What's the second one? Side, side, angle. And angle, angle, side. Okay? These two are, they're not the same, but they are solved the same. Okay? Since we have 2 angles in the side. This is the case that we are going to talk about today. We call it the ambiguous case. Okay. We call it the ambiguous case because not always is there just one solution. Okay? I'm going to show you a visual here. Okay, so just sit back and watch. All right, so what is in blue are the items that are given to us. Okay, so side, side, and this blue angle here. Okay, so the blue is our given information. This dotted line means we don't know how long that third side is going to be, so I just potentially it could be really long or really short. And we don't know what this angle is, so we can rotate that around. Now, if we have side-side angle, and our angle is big enough, but this opposite side is short enough, can we make a triangle out of this given information? Will this ever meet this third side? It won't, okay? No matter how big we make this angle, no matter how long or short we make this side, they're never going to meet. So it is possible that we don't have a solution at all. It is possible that I give you a side, and an angle, and it doesn't even make a triangle. Now, here, okay, because we don't know how big this angle is, okay? But here, if we rotate it around, does that make a triangle? Okay, so here is a solution to our triangle. Okay. Now, if I make this just a little bit, we'll see if this will work. Okay. Now here is a triangle. Technically, so is that. Let me do it again with a shorter side so you can see a little bit better. Okay? That's a triangle. That's a triangle. So potentially we could have not one, but 2 triangles that satisfy those 3 pieces of given information. Okay? So this is why it's called the ambiguous case. We could have no solution, we could have 1 solution, or we could have 2 solutions. Okay? Now, let's talk about this 2 solution case here. This missing angle C, I'm going to call that C1 for triangle number 1, and this angle C2 for triangle number 2. Okay, so I want you to really take a look at this. This angle versus this angle. Do you think there is a relationship with angle C in this triangle and angle C in this triangle?
They're both the same, like, angle away from 90 degrees.
Okay, let's come up with a different way to describe that. Because you're on the right track.
They're supplementary.
They're supplementary, which is kind of what you're going with, okay? So that's going to make it nice when we're finding two solutions, okay? Gosh, darn it. These two angles are going to be supplementary, okay? So when we have the ambiguous case, sometimes we're going to have two triangles to solve out, so it's kind of like we have two problems at once. But sometimes we get no solution and we don't have to do any work. So it'll even out in the end, okay? But we need to see what happens with each case. All right?
There is one solution, will there always be two?
No. Because, and let me go back to a one solution one. Well, that was okay, so here's a one solution one. If that third side is long enough, it will meet once, but not twice. It's too long to make that second triangle, okay? So, there's going to be all three different types, okay? Now, since there is the possibility of a second solution, if there is at least one solution, I have to see evidence that you checked for a second triangle. And I'll show you how all of that is going to look. But if we get a solution, we have to check for a second, just in case. We don't really have a good way of determining if there's one or two triangles off the top of our heads, okay? We're just going to check, all right? And the math will tell us, okay? Numbers do not lie. So, you may want to write down that in the ambiguous case, we could have no solutions. We could have one solution. Or we could have two solutions. I think that would be something that would be good to have in your notes. So what we're going to do first is we're going to look at a triangle that has two solutions. Okay. So here is that given information. A is 40 degrees, side A is 54, and side B is 62. Like we did on Thursday, we need to first determine what given information we have. Do you notice how we have two sides where the angle is not in between? Okay, that is telling us we have side, side, angle, not in between. Okay, tells us two things. A, we need to use a lot of signs. B, it's the ambiguous case. Okay, it is important for you to recognize when we could have two solutions so you can check for it. Okay, so what is the only thing we can find right now? B, remember law of sines pairs angles and sides together. So we know both A's and we know one B. So the first thing we have to find is angle B. So we are going to write the sine of angle B over side B equals the sine of angle A over side A. Okay, don't grab your calculators yet. We know that we're going to need, well, here's the thing. We need to solve for b, which means first we need to isolate sine of b. So since sine of b is being divided by 62, we can just multiply it over. Do you agree? Okay. And if we want angle B, and we know that the sine of B equals that, what are we going to need to do in our calculator? Okay, I'll let you think about that for a little bit. Let me make sure my mode is correct. Every time I close it. Okay, so in your calculator, take 62 times the sine of 40 divided by 54. Is that an angle? It is not an angle, okay? So it would be a silly angle, wouldn't it? Yes.
You can turn that into like inverse sine of that number equals b.
Okay, yes. But since the sine of b equals this number, to get the angle, we need inverse sine. And remember, you don't have to like type this all out again. Say inverse sine, second answer brings up what you just found. So angle B is 47.56 degrees. Okay, now I'm going to show you something that you could choose to use in your calculator. But we could potentially need that answer again. We probably won't. But this will probably be more helpful tomorrow, but I'll show it to you today in case you want to use it. But do you see this STO right here? That's a store button. And do you see how all of these have green letters above them? Okay, so since this is angle B, what I could do is I could say store in alpha B, enter, and then anytime I hit alpha B, it's going to give me that angle B, not rounded. Okay, so if you ever want to like use an answer again later in a problem, you can use that store feature. Okay. All right, so let's come back to our problem. We have found our first angle. Now, we decided that this was the ambiguous case, which means we could have a second triangle. Okay, so what I'm going to do is I'm going to split my page in half, and I'm going to write, all right, we could have a second triangle. Our second triangle is still going to have all of the same given information. However, the angle B is going to be different. We decided that mystery angle from one triangle to the next triangle would have a relationship of being supplementary, correct? So since angle B is 47.56 degrees in the first triangle, then angle B in the second triangle would be its supplement, which is so we have two triangles. Okay. Now, the only angle we are going to do this supplementary thing with is the first angle that we find. The first angle that we find, since it's across from a side that we have, that's going to be the funky angle where it would have that supplementary relationship from the first triangle to the second. Now, essentially, we have two triangles to solve out. Okay, so let's come back to our first triangle. We have angle A, we have angle B. Pretty easy for us to find angle C, do you agree? So since angle A is 40 degrees, angle B is 47.56. What's left over to make 180? Then we need to find side C. Okay, so then to find side C, it's going to go very similarly to what we were doing the other day. Sine of 92 point. I'm going to go up here. The sine of 92.44 degrees over side C. What set of information do I want you to set it equal to? The A's or the B's? The A's. Sine of 40 degrees over 54. So now we can cross multiply to find side C. Have something for me? What? Gabe, did you say something? 83.93. Do you agree? Do you notice how I'm boxing my answers? Boxing or circling answers is what I want to see on your quiz on Thursday. It makes it easier for me to grade. Okay? You're welcome to label your triangle as you find answers, but I do want to see boxed or circled answers in your work. Okay? Also, something I don't know if I pointed it out or not on Thursday, in a few days, I must see your setups. Okay? I can understand not showing this work right here, and I can understand not showing the cross multiplying step, but I have to at least see these two setups right here. The 180 stuff, I know you can do that in your head or your calculator. That's fine. But I need to see at least these two setups. Okay. All right. There is our first triangle. Now let's move to our second triangle. Okay. In our second triangle, we have B is 132.44 degrees. So angle A remains as 40 degrees. So what does that make C in our second triangle? What do you say? 7.56 degrees. Okay. So now to find side C, we're going to take the sine of 7.56 degrees over C and set that equal to the sine of 40 degrees over 54. Which should give us a significantly smaller side because it's across from a very, very small angle compared to the rest. Okay, so what do we get? 06, you said? 05 or 06?
It says 5. Did you guys ground your angle?
Okay. So So, a couple things before we go to lunch. We only do the supplementary of that first angle that we find, and then we basically have two separate problems from there. Always make sure you reflect on your answers to see if your triangle makes sense. Okay? Does it make sense that this is such a small side compared to this one right here? Yes, because it's across from a really tiny angle. And this is across from a large angle, right? Same thing over here. Our big angle across from our big side and small across from small. Okay? Always reflect to make sure your answers make sense with your triangle. After lunch, we will look at the one and no solution case. Now you may go. Okay, on to the next example. Please go ahead and copy this information down.
There's one solution, is there a solution?
We will find out. Don't want to give away any tea.
How do we know that it's two solutions?
Well, we know that it is the ambiguous case, and so we need to check for two solutions, but we do not know if there's two solutions until we check. And I'll show you what I mean by we will know.
Probably.
Huh?
Is it probably?
Probably in this example you think so? Okay, so we have two sides and an angle not in between those two sides. So we do have the ambiguous case. All right, so the first thing we need to find is the sine of angle A, because we have side A, and we know both sets of the C's. Okay. Remember, when you have sine of an angle, in order to be able to solve for that angle, you're going to have to do the inverse sine to get that angle measurement. So multiply that 205 over, and then with that number, take the inverse sine. Remember, a number less than 1 probably doesn't make sense. Angle A, what is it? 21.99? Mercy figured it out. Yeah. Okay. Are we all okay with 21.99? Okay. Since this is the ambiguous case, we do need to consider a second triangle where all of the given information is still the same. Okay. For our second triangle, we take the angle that we solved for and we find its supplement. What is the supplement of 21.99 degrees? Does anybody have an issue with 158.01 degrees as our second angle? What's the problem? If you add 35 degrees, our given angle, to angle A, that's more than 180 degrees, isn't it? Okay. Which means a second solution is not possible, and we only have one triangle. in the case of side-side angle, if it is one solution, I better see that you checked for a second, because if you don't, you will not get full credit for that problem. We don't know if there's a second triangle or not until we check. If our angle is too big, that second triangle doesn't work. Okay. So now we have two less things to find. Let's just focus on our first triangle. If angle A is 21.99 degrees, we have a given angle C of 35 degrees. What is angle B?
123.
Isn't it nice when you get to a third angle? It's a kind of a sigh of relief. Thank you. Okay. And then to find, let's see, side B, we know that angle B is 123.01 degrees. So sine of B over side B equals, what pair of information do I want you to use for this ratio, for this proportion? The C's. Sine of 35 degrees over 314. When you do that cross multiplying, what do you get?
Yeah, 459.07.
459.07. Does that make sense? Cross from the biggest angle, it should be big. Our smallest angles across from the smallest side, so it makes sense. When it is that side-side angle case, you have to check for that second triangle, and I need to see that you checked for it. I know some of you are going to be able to figure out that supplementary angle in your head, but you need to write it down for me to see. All right, you guys are all itching to know, how do we figure out if we don't have a solution, right? Okay. Write down this given information. Okay, so we have side-side angle. We know it's the ambiguous case for the law of sines. All right, so we're going to set up our proportion here. We need to find angle B because we have side B, and we know angle A and side A. Okay, now I have a 30-degree angle picked for a reason. Before we start getting all excited with our calculators, let's think about this. If we're going to solve for the sine of B, we would multiply that 6 over, correct? What is the sine of 30 degrees? 1/2. What is 1/2 times 6? The sine of B is 3/2. Go ahead and take the inverse sine of 3/2. Tell me what happens. There is an error. Why is there an error? This is larger than 1. And remember, sine is going to have values in between -1 and 1. So If that happens to you, okay, I wanted an obvious one so we can see it, but if you say inverse sine and it gives you domain error, you do not have a solution. There is not an angle that can satisfy that ratio. So no triangle. And your problem is done. And that's all we have to do. So, what I'd like you to do, because I want you to start to practice this while you're with me right now, get out a book, and you need to try a couple of these problems on your own. So whether you have one book out for your entire table to share, or two books, I don't care, take a picture of a book. You need to do, I'm going to say, you have time to do at least 2 problems before you leave. I think you can get 2 problems.